This is a cut down version of the music playlist app that we've just finished working on, and I just want to point out a common mistake I saw quite a few of you doing. So here we've got the draw menu function that just outputs the menu options from an array that's passed as a parameter, and I've just cut it down to two different menus. We've got main menu here and create user, and so you can see that if I run it, we've got the create account option, and if I choose that, it takes me to the create user, and then if I click 2, it takes me back to the main menu, and I can do that backwards and forwards. Okay. Now let's just have a look at how it does that. This is the way that a lot of you did it. You've got your sub main menu, and if you choose option 2, say, it calls the create user function, and then we jump down to create user, and we can see it's doing the same thing. We're displaying a new menu, and if you choose 2 on the menu, it calls main menu. Now that probably seems like it would work just fine, but let's have a look at the consequences of doing that. If I already showed you that I can do 2 to go backwards and forwards between the 2 menus, so I'm now just going to automate this. Instead of asking for user input, I'm going to call create user directly. So we won't wait for the user to type something in, we will just jump straight to the create user menu, skipping this bit of code. And I'm going to do the same thing in create user. I'm going to call main menu without waiting for user input. So now what we've got is something that is going to jump backwards and forwards between main menu and the create user menu endlessly. So let me just run that. Okay, it's flickering much quicker now because it's not waiting for user input, and it's going backwards and forwards. Now this is going to take a little bit to get to the bit I want to show you, but let's just think while we're watching what's happening. Every time main menu is called, we are starting a new function call, so the parameters that you're passing get pushed onto stack memory along with any local variables that are declared inside the function. And when we call create user, it does the same thing. Now look what's happened here. Our program has crashed, and we've got an unhandled exception. I don't know if you can see that on the screen here, but it says a Stack Overflow exception. Now the reason that's happened is because we never actually terminate any of the functions that we call. When we call, let me just stop it here so I can show you the code quickly. When we call main menu, we're calling create user without main menu ever finishing. And then we jump into create user and we call another copy of main menu without closing this create user or the first main menu that we called from. So we're bouncing backwards and forwards between these 2 bits of executable code, but every time we do that, we're pushing a new set of parameters onto the stack. So we're creating an array, a local variable array of the menu items, and that local variable gets pushed onto the stack each time. So backwards and forwards, we're pushing this array of strings onto the stack. And the stack only has so much space. Eventually, we have filled the stack up so it crashes into other parts of memory. At that point, the program crashes. Now, it takes quite a long time to happen because modern computers have plenty of memory. And it took us sort of 30 or 40 seconds of running much faster than you would normally when your code is executing. But in a way, that makes the problem worse, because imagine that you're a professional software developer and you've shipped this code to a customer. In your tests, it works fine because you're only jumping backwards and forwards in the menus a few times. But then they have this installed in their office or whatever, and they run it all day, and maybe after 6 or 7 hours of using it, it abruptly crashes. And at that point, it's a very difficult error to track down, because they will say, well, all I did was jump to the main menu, which I've done loads of times, and that normally works, but this time it crashed it. So this kind of memory problem is called a memory leak, because you're effectively leaking the available memory that the program has to use with each function call. There are other kinds of memory leak, but this one is caused by leaking stack memory. So let's see how we fix that. So here, when we call our main function that runs when the program starts, all we're doing is jumping straight into the main menu. But I don't know if you remember, when I originally showed you how to do the menuing system for the music playlist, we actually did it using states in a finite state machine, jumping between different states. So here I've got my states defined, and what I'm going to do is change main menu from, instead of being a sub, I'm going to make it a function. So that's a function that returns an integer. And instead of calling create user, what I'm going to do is return a value, return the value of the state that I want to jump to. So I've defined them at the top here. So we want state create user. So return state create user, and space that so it's clearer. And I'm going to do the same thing here. I'm going to change create user from being a sub to a function that also returns an integer. And instead of calling it directly, we're going to return state main. I think it's called here, state main. Okay. So now, when main menu wants to jump to the create user function, instead of calling it directly, what it does is pass a return value out of the function. So we need something that's going to receive that return value and do something with it. So before we just had main calling main menu, and that's all it did. What we're going to do is use a different version of main down here. I'll call it main2, but I'm just going to change that back to main so this runs. I'm going to change this one to old main so that it doesn't run when the program starts. Now let's have a look at what main does. Comment those lines. So now the main loop starts in state main, and then we have this loop here that is endlessly cycling round, checking the value of this state variable. And on the first pass through the loop, state is set to state main, so this if clause passes and it calls main menu. So at this point, when the program first runs, it jumps up to the main menu function. Here's main menu up here, and it displays the menu, and then it returns state user. So at this point, when we get to the return statement, the function quits. So whatever was pushed onto the stack at that point gets popped off. That memory is reallocated. We don't have a memory leak. Main menu has quit. It quits back to where we called it from, which is this main loop here. And this loop finishes that pass, and it goes round again. But notice, when we called main menu, we were setting the return value and storing that in our state variable. So now state is set to whatever main menu passed, and it passed state create user. So then the while loop goes round again, and this time the if clause doesn't match on this clause, it matches on the else clause, if state equals create user, and so it calls the next function. And so then we call create user, and this one again returns state main. So again, the function quits, whatever variables were pushed onto the stack get popped off, the memory is freed up, and the return value is saved into the state variable, ready for the loop to go round again and recheck it. So we can hop backwards and forwards this way for as long as we like. I will run it just to show you that it does, but we could sit and watch this forever, and we will never run out of stack memory, because whatever gets pushed onto the stack is always popped off before we call another function. So this way avoids the memory leak. The other way, what you're effectively doing is a form of recursion. Normally we think of recursion as one function calling itself multiple times, and every time you recurse, you're adding another stack frame into the stack. But recursion can also happen when you're hopping between two functions backwards and forwards, or between more than two, just in a circle. One, A equals B, B equals C, C equals D, and D equals A back to the beginning. That's still recursion because none of them are ever quitting. They're all just adding a new stack frame, chewing up a bit of memory. And you can get away with it for a while, but if you've ever accidentally done it in a way that will happen endlessly, you will always run out of stack memory. No matter how powerful your computer is, it will crash eventually. So let's try and avoid that.